Sobre how the number one is designed. And we are, yes, they are not, we are doing this, we are doing this. And in Argentina, and actually in America, they are not even doing this. It's just, for them it's a set. Because it's a set. Wow. And it's magnetic. Wow. Oh, thank you very much. Hola. Nice to see you. The cheers and the More power cords, no? Power strip there. Hi, how are you? You need one? He was waiting for you. I tell you, hey, don't touch What do you like most? The in stop or the in stop? Connections. Like more, it's more. Yes, yes. Yes, please.
Anybody else?
You're a ninja.
Ninja? Ninja? I'm ninja.
Not ninja.
Maybe Mark was broken. Throw it away.
No, it's not mine.
Please do. Because then people borrow it. They have no work.
Wow. He has my same device in here.
Sorry, it's yours.
Hi.
Why am I?
From here. You can ask her. Remember the stickers? Is one more? There are more stickers. Free stickers. Is here the owner of these? The first class, somebody left these? No? Okay. Remember that that's the Wi-Fi password, you already know, if you don't know. And also, this, I will talk more about this later, but this weekend there is a security conference in Brno, security sessions. So you can go there, it's this Saturday. Will be very, very nice. Veronica will be giving a talk in there, and I will we've been talking also on a workshop, so you can go. I don't remember the time. And here, today we are going to pickups. Here are the big links, also the document. If you have the document online, it's there. You can start and load with them if you need them. And also we will, in the middle of the class today, during the break, I will give you time, but if you want, you can fill the survey of the seminar. I will greatly appreciate if you do that. The purpose of the survey is because the university wants to know, like, if this was a good idea or not, we should continue doing this type of seminars or not. So they want to know your opinion on this. So if you can, please fill the survey and that will be awesome. So what is it more?
Tipo más marketing después en la página.
Sí, no quería hacer token.
No linda tanto de las caras, por ahí arriba. No sé si
Sí, sí, no hay problema.
Okay, so let's start. So everyone, welcome to the last class of the seminar. I'm not sure if it's good because it's ending or because it's the end. I don't know. Has been very nice, but now I can sleep again. So today we have the last class. I hope it's not too long. The topics are actually a lot, but I hope we can work on them smoothly, right? It's not a lot to do, it's a lot to explain. So today, if you remember, we were working a lot on the first class, basic introduction to TCP networking, how to sniff, what are we doing, why are we doing this. Then we move to malware, capture malware, you execute your own malware. And today what I want to show is how we can continue in this path. Right? Okay, we have the flows, we have the traffic in there, we have the malware in there. What can we do do this. Like if you remember, we were trying to detect these malicious behaviors in there, the botnet attacks, we were trying to detect the normality, and it was quite difficult. Remember? It was like, maybe no, you are looking at something and you say that something is there, I'm not sure. So if you're trying to analyze only one capture, only one attack, this is quite simple or easy or fast. You can use wireshark, TCP/IP, and that's it. But you can imagine if you have to analyze the traffic of a big organization, of a big network, you don't have the time nor the resources to analyze this by hand, packet by packet, right? And this is an issue. You cannot do this. Nobody can do it. You need a lot of people. You don't have the money for this. So this is where you say, okay, we should automate this analysis. We should automate the detection. And how we can automate the detection? Actually, which are the best tools you know right now that anyone can use for detecting attacks automatically in a network? What do you know there? Now I say good ones. No, sorry. Stratosphere, thank you. Snort. Omnidic, also Bro, Suricata, Yacht. So we have a lot of ideas in here, and they are very good, right? Actually, very, very good. Which are the most important problems of these tools? Why we are not using Snort automatically, for example, for blocking the attacks? Why nobody say, yeah, I will use Snort, and whatever Snort is detecting, I will go and block automatically? False positives, right? Remember about this? The thing is that when you play this in a very large network, you have false positives. And for example, in Snort, whoever installed and used, and more importantly, configured Snort in a real network. Suricata is okay. So you know this is very difficult, right? You are running it, oh, awesome, there are a lot of alerts. And then you look at the alerts, 1 hour, 2 hours, then there are too many, and then you just start saying this is too much, and you stop it, and you start configuring to only detect the most important stuff, and after, I don't know, 1 week, nobody's watching. Like, it's too much information, actually. So this is a problem with automating. And today we want to talk about this issue, okay? So we will start with flows. The first thing that people is doing to use this traffic in the organization is creating flows. So let me talk a little bit about this. Before continuing, remember that we are being recorded and monitored, okay? Just in case I have to say this. Just remember. Video, audio, and networking, okay? So, what are flows? Who knows what are flows in the network?
Yeah, that's they are the information about the packets, about the connection. That means, for example, the source IP address, destination IP address, port, protocol. I don't know.
But what is differentiating flow in that case for a packet, for example?
The packet also carries the payload.
Okay.
But the flow is just the information about the connection.
Okay, and more important, it's okay. There is something missing there. Big difference.
It's a conversation. One flow is one conversation.
Okay, one flow is one conversation. That's exactly. Yeah.
Flow is kind of phone bills.
Sorry?
Phone bills. For example, they have duration and they have source and destination. There's ports, but not content.
Okay, yeah, it's true, but there is more close to what he said. That a flow, it's an aggregation of packets. It's a connection. So in one flow, you have actually many packets, hundreds, thousands of packets. And this is the most important stuff. You are getting one connection. You remember when we were saying TCP connections? So you get all the packets in a TCP connection, right? All the packets, and you don't have time nor storage for for storing this packet. So what are you doing? You're taking all these packets and you are creating only one flow, okay? So in the flow, usually you don't have content, so you just aggregate the information. You say, okay, there is only one source IP address, so I can put one IP address, only one port, protocol. What about the duration? So the duration is the duration of the flow completely. And you have more information like number of packets, number of bytes, and more stuff in there, okay? So you can actually compress a lot the network information in just one line. And that is why flows are being used. Actually, there are several standards. The first standard was NetFlow, created by Cisco several years ago. Most used, very, very good one. And now we are trying to migrate to IPFix, the new standard that is also being pushed by Cisco and a lot of other people, that is more flexible and everything. So this is why we are using flows, because we can capture a lot of information very fast and very quick. And for this, we have also the thing about privacy. So if you're using flows, you don't have the content, so you can get information from other sources that it's not your network, and they don't care about the privacy anymore, right? So what do you think about this? Is this true? This is okay? It's completely okay? There are some issues in there? Like, yeah, if you're using flows, your privacy is 100% protected and it's completely, let's say, anonymized or something like that.
It's not.
It's not.
Like, not at all.
Not at all. Oh my god. He knows something. Yeah. Why? No,
Well, because you can reconstruct the traffic. It's the metadata thing. Like, for example, the secret services are collecting this data and doing intelligence.
Okay, yeah. So I don't know nothing about intelligence services, but now it's true. This is called metadata. So actually, there is your source IP address is in there, right? So this is not completely anonymous. And also, okay, I don't know what are you doing. I don't know the content, but I know where are you going. Destination IP. So actually, with time, it may be possible to use this metadata to create some type of profile or behavior of what you're doing. And this is exactly what Stratosphere is doing. We are creating behavioral profiles in the network. We don't know what you are doing, but we want to know how you are doing it. Okay? So it's true, privacy is there. You don't have to worry about the data, but you should know that the metadata may leak information about yourself, okay? So just be conscious about that. Also, we have a very large distribution, very large distribution of sensors. So you can get, for example, flows for a lot of routers, and you can get all these together at the same time. This is much easier than just sniffing the traffic out there, okay? So, we are going to use a tool called Argus that you are going to have to download this and this to install. So if you want, you can start. And why we are going to use this tool called Argus? There are a lot of tools for managing flows, okay? And we are going to use Argus because it's first is bidirectional flows. It's having bidirectional flows. So the NetFlow standard, by definition was unidirectional, okay? So, in the NetFlow standard, if you are sending flows, imagine that you are host A, and this is some web server, and you are sending a packet, and the web server is telling, hey, yeah, you can connect, and then I connect again, right, sync add, and then you push some data, and then he's sending back something, and then you close the connection, fin, add, doesn't matter. So if you're using NetFlows, from here you have actually two flows. The first flow, it's about everything that was being sent that way from A to W, and the second flow is everything that was sent the other way around. So this is very good, but it's tricky because actually you don't know everything that happened there. And trying to figure out which flows corresponds with which other flow is very, very difficult, if not impossible sometimes. So that's why I prefer not to use the NetFlow standard, and I prefer to use Argus that is compatible, but it's bidirectional. So in Argus, we have all the information of everything in one flow, okay? This is the best difference in there. So, Argus also is a very, very fast tool. You can imagine that Argus is being used in, I have to say, a large amount of US government organizations for capturing the internal traffic. So those are very big networks, and Argus can work there. So if you have a very big network, it can work perfectly. Also, you have a distributed architecture. It means that you can have, for example, several Argus. They call them Argi, right? So you have several sensors there, sending information to a central Argus, and then you can query this Argus, and you can create a database, and you can also send this to another Argus that is going to split it. So it's very modular, and with Argus you can do a lot of information capturing from there. Okay, that's something we really like a lot. Especially because, imagine that I want to capture the information in his computer, right? So he said, hey, I want to give you my flows. So there are two ways of doing this. Or I connect to your computer and I ask for the flows, or you connect to my computer and you give me the flows. I'm quite sure he doesn't want me connecting to his computer, so it's very important that the client has the ability to connect back to me, okay? So that's something that is happening with Argus here. So let's try to install it, please. So go there and download it from there. Remember to install the libraries first, okay? Those that fit in there, and then you can follow the instructions. Did you already install it? Or you are working on it? Yo. You ready? You're compiling? Downloading. Ah, oh my god. Why are you doing that? Was not working? No, was not operating? Ah, okay, the last nightly build. Okay, the last night compilation. So, download from there. Do you need like larger font in there? No? It's okay.
Maybe just the URL of the document?
The URL, sorry? Like bigger?
Yes, I guess there are people who don't have it. Or Bitly, is it?
You say like not that URL in the document? Yeah. That one is in the document. Or I don't know.
Yes, did you send the
document? Yeah, it's public, right? You have the document, right? Yeah? Okay.
Maybe write the right link. Yeah, that's for the survey.
You want for the document. Okay.
You have link for PCAPs, you have that link for survey, right? Not for the document.
Let's put it for the document. So, wait for it. Thank you. Make it beautiful here, just in case. There. There. Veronica is writing the link to the document. Also there. Thank you very much. I completely forgot. Configure. Make. Yeah, what do you do? Make or configure? Perfect, that's it. If it's working, you can type Argus, enter, or something like that. No. Yeah. So try again. The configure. Was an error?
Yeah, I couldn't see because
Okay, next. Maybe so. I think so. Oh, because you're not a client. It's okay. You should only do the run. For example, yeah, it's okay. You can contribute. Yeah. So do the same for the Argus and for the clients, okay? So Argus is the main capturing tool, and the Argus clients are the small programs that can deal with the Argus data. The good thing is that Argus is using a special binary format for storing the data. So when you capture the Argus flows and you store them, it's very fast, efficient, and small. Actually, Argus can read compressed files. So you can compress the files on this, and when you read files with the tools, it can read the files already compressed. So this is very nice. Just to give you an idea of the performance, we are monitoring a network with close to 3,000 hosts. So 3,000 hosts is a lot of hosts, and we are storing all the flows, including some data I will show you now, for 1 year in less than 800 gigabytes. That is nothing.
That's nice.
It's very nice. 1 year of 3,000 hosts with some data for us was a very amazing tool. So, tell me when you finish installing it, configuring it, and then we can start working with it. I will try to turn this around. So, there we go.
Question? A small mistake.
Oh, sorry, where?
It says same instead of idem.
Where?
Below idem, instead of idem, it should say do the same or
Should say what?
do the same as above, I guess.
Okay. You don't like either item? I can do that. Do the same. Idem. Repeat. Also, download the configurations from here, from Mega. You have the URL. Oh, there. Thank you very much. That's the Google Doc. Download the configuration of Argus and the configuration of RA. RA is the main Argus client tool, and so we have the same processing. It's very good idea to have the same configurations. These are not the default configurations, just mine. Did you compile it? No? No compilation? Yes? Compile? Super. Compile? Did you compile the phone? Are you compiling it like looking at So once you download the configuration, please move them or copy them to /abc. So we have them there. Okay? Are you following here? Good?
Is the version 3 point something necessary?
Well, should be 3.8 up, not the 2 point something. Yeah, because there is an Argus in the Debian system, but it's too old. We need this one. It's so old that we can almost do nothing. Actually, that version is, I think, for 3 years ago. I'm sorry. I want to use it, but sorry. Actually, we can prepare a CAD distribution with all the tools for the seminar I will install, right? Somebody can be kind enough to do that for us and publish it. There? Is it working? No? Yes? No? It's not compiling? Or what? In what?
Many errors.
Oh, okay. Why not? But it's all there. Just open the tar, getting ./configure. Are we ready? Can we continue? Yes? Okay. Come on, Jana. Okay, so what you can do is that you can actually use Argus like this to read directly the packets from the network and print them in the console, okay? So let me show you how this may work. Wait for it. So I will show you something there. Oh, come on. Oh, sorry. So I'm running this in my computer. Remember that I just put the Ethernet connection for your HANI, but if you are using Wi-Fi in your own computer, just put it there. So this is actually how an output of flows may look like, or actually looks like. I will give you a small clarification here, just for the record. Actually, NetFlow is a protocol for much more than just printing these pretty lines. It's for communicating and sharing the flow. So the standard includes how to communicate, the binary protocol in there. We are not looking into that, right? We just care about generating the flows and printing in something like that, okay? So here we have flows. Can you see that in your computer? Yes? Everyone? There? Flows? Working? There? So, in the first column, this is a comma-separated values, CSV. So, from here, what my pointer is, from the beginning to here, we have the start time of the flow. And something very, very important, we are using microseconds. So after the seconds, 28 seconds, we have 6 numbers, okay? And this is very important for the precision. If you only have milliseconds, you may have issues with the behaviors. And why is that? Why do you think we need microseconds and not milliseconds in the precision?
Know the order? Know the order? Which?
Well, actually, yeah, because if not, we have a lot of things in the same millisecond and we lost the order. That's very important, yes. And related to that is that if we have a lot of information, like a big network, we will have a lot of flows with the same start time, okay? You can have actually several thousands in there. So this is not a good idea. You need more precision to be able to differentiate them. And what he's saying about the order is very important also, because in the behavior we will see tonight, if the flows are out of order, we don't know what's happening before what. So we need this order in there. Not precise, you don't have to be strict in there, but some order, okay? So, and then we have the start time, comma, the duration of the flow, comma, the protocol, main protocol, UDP, logical layer, comma, and then we have the source IP address, comma, source port, Then you have the direction of the flow in there. You will see these, for example, are bidirectional because there were data going in both directions. Then you have the destination IP. Then you have the destination port 53 in this example. I will stop the scrolling so you can follow me. Right? And then you have, after the destination port, you have the state of the flow. So what is the state of the flow for you? What do you imagine is the state of the flow?
In which phase the connection is, and it's connecting or it's already connected.
Very nice. Exactly that state of the connection behind by what? For example, imagine TCP. Okay, so am I capturing a complete established TCP connection, or am I capturing just the initiation of the connection? And why do you think this is important? What do you think having this difference between the connections that want to connect and the connections that are already established is very important? So remember that if a connection is sending SYN packet, SYNAC, and ACK, at this point TCP is saying this is a established connection. And if you only see one packet, this is a connection that is being initialized. Also, if you only see the second packet, only when you see the three of them, you say the connection is established. The same for the finishing. So why do you think it's a good idea to make this difference in there? I can wait. Come on, which is why? Why do you think it's important? Think about port scanning.
Well, the connection never gets actually, connected. The other side might try to respond, but it's still in the connecting phase, so it never tries to connect. So that's why it's important to distinguish it from the case when the connection is successfully connected and it ended.
Yeah, exactly. So if you don't make this difference, you will have a lot of initialized connections. Imagine that if you are port scanning one computer, most of the packet will be only initialized connections. And only if one of the ports is actually open, you will have an established connection. So only looking at this stated here, you can differentiate if a port scanning was targeting a filter port or an open port. And this is very important information, especially if you want to block this guy. So the state is giving you a lot of information on what's going on in the network, right? The problem is, with TCP, everything is awesome, right? The problem is, what about UDP? How do you know the state in UDP? Which is the state in UDP?
Stateless.
Stateless. There are no states. Nobody knows the states. One UDP packet, enough for me. It's established. 2 packets, better, established. 3 packets, I don't know when one is sending. So there, you don't know how to differentiate. Also for ICMP, also for IRP. So sometimes it's very difficult to have this information there. That's why we want more flows, so we can actually analyze the behavior and say, okay, this should be working because then later you did that and you did that. And then you have there the amount of, you have the type of service source, type of service destination, no one cares about that. It's always 0 most of the time. And then you have the amount of packets, 2 packets, and then you have the amount of bytes. And listen to this, very nice piece of information. The amount of source bytes. And this is something that is not in the NetFlow standard and was, for the first time, I think, was put into a NetFlow by the Argus tool. Argus can tell you that from the 216 bytes, 83 was sent from the source to the destination. And again, why this is important of course, every time I'm asking why this is important, I'm focusing on network security and detection, okay? So think about why or how you can use this information for actually detecting an attack or an intrusion or malware or something suspicious, anomalous. So you have the difference between the source bytes and the total bytes.
Distinguish between download and upload.
Exactly. And this is important because if you can distinguish between what's being uploaded and unloaded, you can match this with the type of connection. For example, if you are connecting to my web server, I'm expecting that you will be downloading much more than you are uploading, right? Because it's my web server. What are you going to upload? Maybe your name. And you are going to download images, JavaScript, HTML, a lot of stuff. So if you see one connection to my web server, but you are uploading more than you are downloading, oh, this is an alarm. Like, why are you doing this, okay? Do you remember in the second class when we attack this web page and we upload and we start messing with the commands in there and we are executing a Python and all this stuff? You remember? Mm-hmm. So in this type of attacks that you are putting things inside the web page, this ratio is moving. And you can use this ratio maybe to detect something like an SQL injection attack. And this is very, very, very important, right? Sometimes you can detect very complex attacks only looking at that. The same with SSH. Like, if my SSH is only for downloading stuff, like scopy, SCP, and you start uploading, this can be quite difficult. Something I forgot about net flows. Question. Another thing why net flows are very important and very different from analyzing the content of the packet. When we are analyzing the content of the packet, we call it deep packet inspection. So, which is the difference, main difference between looking at the content, trying to see that, hey, this is a web page, and only using flows. Something that nowadays is very, very important also.
Do you only extract the data from, I don't know, 4 layers, initial 4 layers, not from not the actual content? You stop right at the where it is like transport layer.
Exactly. So that is something that the content of the packets are not reflected in the network. That's completely true, right? And sometimes you cannot do this because we are now okay. Why we can read these things in ASCII data? It's not encrypted, and that's the difference. When the packets are encrypted, you cannot look into the content anymore. So all your snort rules do not apply anymore. You cannot detect an SQL injection only looking at that because now every web page is encrypted. But using flows, you may still have a possibility. No such a big possibility, maybe no, but it's better than nothing. So now, a lot of tools that want to deal with encrypted connections, they can go to flows without any problem because they can work in there, okay? So, let's continue with the flows. Can you see this? Everyone was looking at the flows. This is very important for the rest of the seminar. Okay, so, about the parameters in there. Read the configuration, capital F. Then we have the capital S, that's the report time. Maybe the most important parameter in there. The report time is how much time should go by for the Argus server. You have Argus in there, Argus. And Argus, if you look at it, Argus in here, it's reading from this interface and then it's writing into a file, but I'm not giving a file name, I'm just putting a dash in there, right? That means write the output output of the binary Argus to the standard output. And then we pipe this to the rack tool, and we say, hey rack, this is your configuration, and you should read from the standard input, okay? Do you got this? About the W and the R? Everyone got it? Standard output, standard input? Yes? No? Okay. So, and then we say, again, -n, do not resolve DNS, and then we say capital 0, B, that means give me the content of the state. Do not summarize me the state. That means if TCP is sending the bytes SYN, add, and everything, I want to see the letters. Don't tell me the connection is established. No, I want the details. That's what it means. I want the details. So, why the report time is so important? Because Argus is sending information to run about what is going on in the network here. So here you have the network, these are the real packets. Argus is reading this. And now, imagine this. Argus is reading a packet. Okay, yeah, I got a packet from you to you. Okay. When should Argus report the flow? Because Argus will say, okay, no, wait, he should be answering now. Wait. There, he's answering, so now I'm waiting for you. Oh, there, you send an ad, so this connection is established, okay? But then I have another one there. So he sent a packet to the other network, and I'm waiting for the connection. How long should Argus wait for this? Forever? What do you think? Do you understand the question? No. Yes.
According to some standardized timeouts?
Standardized timeout. So, did you understand what he said? Standardized timeouts? He says, hey, there are standard timeouts, actually the implementation of the protocol in the RFC, in the documentation that says how much you should wait, for example, for TCP to time out. Did you ever try, for example, I strongly encourage you to try this at home. If you connect this computer with this computer, I don't know, using Wi-Fi, Wi-Fi is not so fancy. Use a cable. So you use a cable for this, and then you start transferring something using FTP or something, right? And then you just unplug them completely. When is the FTP going to say, hey, I don't have a connection, I should stop doing this? When? Should it? So there is a timeout in the protocol. It's long timeout. Something like 1 hour or more. So if you wait 20 minutes and you plug the computers again, they will resume and finish. No problem there. It's an amazing experiment. And this is working in internet all the time. So how long should Argus wait? 1 hour? 2, 3, 4? At some point, Argus will say, okay, stop. I should consider this connection finished, okay? Now that Argus have this information, when should Argus tell me about it? Like, hey, look at this. I have 5 flows in here in the network. Should I wait more? Or do you want the summary now? So what I'm saying there is report to the RAD program every 5 seconds. That's why we have so many flows in here. Sorry. That's why we have so many flows in here. Because every 5 seconds, Argus is reporting the same flow again and again and again, like this one. This is actually the same flow that is being reported every 5 seconds. So we will look at this later, but this is a very important piece of information for any flow connector, okay? Any flow connector, including the net flow. So let's continue here. So very, very nice feature of Argus that you can add this string to the RAM. So add this string to the end of the RAM like this. I can do this maybe. Oh, come on. Okay, so to the end of the RAM. You can add that, just like that, and it means, give me 2 more columns. The first column is the source user data, and I want 400 bytes of the source user data, and then destination user data, 400 bytes. And this means that actually Argus, let's wait for it, let's try to navigate something in here. There is working. There. So actually it means that Argus, it lost my pointer. There. It means that Argus, nice to see you. It means that Argus can append information from the content in the network. And this is very important for monitoring because originally flows do not add any content. Remember this, right? There is no content in the flows. But if we want, and we have authorization, we can add this and add our analysis, okay? So in this case, it's very nice that we can have some bytes from the flows in the network in there. Okay, can you see this in there? Why this is still better than using TCP/DAM? Because in each flow, you have a lot of packets. In one flow, you can have, I don't know, here we have only one, but you can have, I don't know, 200 packets in one flow. And you don't care about the complete content. Most of the time, you can tell a lot about the content only looking at the first bytes. Like in HTTP. When you are sending something in HTTP, you say, hey, here there is an image. That's it. Then you can see the image, the 3 megabytes of binary content. You don't care about the content in binary. You just care about, hey, he was sending an image. So you can do this, but appending that in Argus. Okay? Can you see it there? Everyone? Yes? It's there? We will use it later. That's also why we are using Argus and we are not using any other flow tool. Because this is helping us in the analysis. Okay? So, there we go. Another thing I want to tell you is that if you are using Argus to read a pickup file, not an interface, but only a pickup file, you can use -F and Argus will keep reading the file, waiting for the packets to arrive. And this is amazing, for example, for the TCP/DAM file that you are generating from VirtualBox in real life. So you can actually start having a pickup file with the malware traffic. You can run Argus on that file, and even if there are no more packets, it doesn't matter, Argus will wait, and when the malware is doing something, the packets will go to the file, and Argus will read it. And that's a very nice feature. Actually, I should thank Carter Bullard. Carter Bullard is the owner or first creator of Argus, and he put that feature in there by request of our Stratosphere project team. So we need that, and we asked him, and he was kind enough to put it there. So it's especially tailored for this malware type of traffic. So I highly encourage you to take use of it. So, when I'm using the report time I was telling about in the configuration files of Argus, I'm going to use 1 hour. Okay? We are not going to use 5 seconds anymore. We are going to use 1 hour. Can you imagine why? Why we are moving for a 5-second report time to 1 hour report time? Why are we going from using Argus to report the flows to the client every 5 seconds? That means read the packets. 5 seconds later, just stop and give me what you have. I don't care the state, I don't care nothing. Give me what you have. So you will have a flow. Imagine that you're downloading something from the web. You will have a flow with only 10 packets. You actually know that the download is taking thousands of packets. But in that 5 seconds, we just saw 10 packets. And then in the next 5 seconds, you will see another flow, another flow, another flow. So we are going from that schema to waiting 1 hour, and the Argus is reporting the complete flow. So why are we doing this?
We probably want the flows to be less fragmented, meaning not like 5-second fragments of a flow and have 1,000 of them, just having, I don't know, 2 or 5 of them, or just one.
Oh, just one, exactly.
Less than one.
Okay, you got it? Why? We want something closer to the complete flow, the ultimate flow. And this is impossible to get. Because again, okay, another question. Very, very nice experiments that you can do at home. How long, again, not how long, how much is the total time that the TCP connection can be active and working?
1 week. Like
1 week? Forever. Oh, you are pushing me. 1 week was a lot. But okay, there are reports of connections there sending packets by month. So there is nothing in the protocol stopping you for being there sending stuff like 2 months, 3 months, I don't care. One connection, right? So as far as we are talking and we are not missing the time out, we can keep doing this for a long time, maybe forever. You should try. You should try and then send us a screenshot of, hey, 3 years.
Right now in Photoshop.
Oh, you are I want the real stuff. And then you have it power out of your computer and say, no, my connection. So we cannot wait. We cannot wait 1 week or nothing. So we are saying, okay, 1 hour because this is a TCP standard timeout for most of the connections. So 1 hour later, tell me what you are in there. I hope I will get all the flow. If I don't get all the flow, it's okay. I will get 1 each hour. Okay? So that's for you to have in mind. Why I'm saying this? Because in Stratosphere, we are using this for creating behaviors. So it's very different if you have a flow every 10 minutes than if you have a flow every 5 seconds, right? It's completely other behavior. So that's very important for us. Okay, so let's try this in these pickup files. Download please these files, and if you are ready, download them. Please run Argus in these files like this. Okay? So it means Argus, read the configuration in this capture one pickup file, write the output in the standard input. I didn't tell you about the filters. Maybe I can tell you about the filters now. So you can filter, just like in TCP dump, you can filter packets in Argus, okay? So let me show you this while you're downloading it. Okay, there. So I will take my Argus. Can you read it there? So I will take my Argus. Look at this. After the dash, I will put 2 sets of columns, and I will say, for example, not UDP. Okay? Can you see this? Okay, can you not read it? There. Not UDP. That means that Argus will ignore the UDP packet. So like that, you can put not UDP and IPv6 and not port 53 and so this is very, 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 very fast. Very fast. Okay, so wait, we'll stop it. There we go. So please run this command in your capture one pickup file so you are not having the ARPs, not having IPv6, so we just cut off all the information, we give it to run, read it, and we see the user data, okay? Pipeless. Let's see what's in this file. Could you download it? Yep. Is it alive? It's working? No? Yes? Oh, I can see your download there. Posting.com. Yes. Oh. Was anyone capturing packets at home? No? No? Very nice. Cafe is awesome. You should go to a cafe. It's amazing. What the people is sharing. Completely legal. Yeah.
So open the window, it's nice.
Oh, the window. A lot of traffic that you don't know why it's there. What you do in Windows, yeah, it's an amazing experience. Amazing experience. Also, it's a very nice idea. For example, do you have DSL internet connections at home? Do you have dynamic IP address that is changing from time to time? Do you? So, it's very interesting to do this experiment. You start capturing the packets that are coming from internet to your home. Actually, for doing that, you need to configure your router because these packets are all the time stopped in your DSL router, so you can configure it to send everything from internet to your home computer, which is actually dangerous because you will be attacked, so. But if you do this, you will receive the stuff from internet. And this is a very nice experiment. Reset your router until you get a new IP address and start capturing, and you will notice a lot of connections going to you with information that you didn't ask because you are not sending nothing. And they actually belong to the previous owner of that IP 10 seconds ago. So actually, somebody was using the IP, Facebook, Twitter, whatever, and then he got disconnected or something like that, and the IP is automatically assigned to you, and Facebook and Twitter is responding to the IP, but that is your IP. So you have like 20 seconds when you get information that is not for you, and that's amazing. It's like, oh, look at this. You may have, I don't know, emails or whatever. It's like, we are sniffing, I don't know how to call it. Nice experiment.
So you have to be really lucky to like capture the data because no one really usually plugs the router out.
Well, you usually try several times, but every time you do it, you get something. Because if you get a new IP, it's because somebody does not have it anymore. So all the time there is something there. Phones or whatever, every time you got something. So, is it running? Everyone is looking at it? So this is the part that you love, because I know you love it. How can you analyze that to show me what is interesting, what's going on in there, which type of culture are we looking at? Is this normal? Is this malicious? Come on, you know the drill. What's going on in there? Only using the flows, okay? I will try, while you're looking at it, I will try to do it here again. So, wait for it. Oh, I have to do it there. So, any idea?
Connect to strange domains.
Connect to strange domains. I like the strange part. Wait for it. I will try to show you there. Connect to strange domains. What do you think? The rest of the people? Can you tell me where there? Just move me and I will there. Down.
Yeah, here.
This one.
Yeah.
What do you think? Connecting to strange domains. I like because you didn't say malicious or normal. You say strange. It's very, very nice. It's like, we need some expert here to verify this. I don't know. So actually, how can you verify if this domain is malicious or not? Oh, you're letting me play. I don't know. Why I never thought about that before? My God. Sorry. How can you check it? How can you check it? Domain malicious. No, not malicious. Yes, malicious. No. Virus total or total virus, you can do that. Oh my God. If you register that domain, you will have thousands of security analysts logging in there and giving you the credential of virus total for sure. This is hypothetical, theoretical experiment, okay? If you do it, so virus total, it's true. Some other reputation system. So did you try? Is it the virus total? It's not? Come on, don't be lazy. You are waiting for me until I say, yeah, it is. No, it's not. So, what else?
There are weird paths.
We are sorry?
Paths.
Path, okay.
Like
Can you point me there?
images.
Like this one?
Like this one, yeah.
Okay, he's saying, hey, look at this. This is a weird path. And why is weird?
Oh, it's too long and
Too long! I really like it.
it could be encoded, like it's gibberish. So, but it could be okay. But
That's my virus.
if it was encoded, it would be short because this is like too much information.
Okay. So at some point saying, hey, this is too long, it's encoded, maybe encrypted, we don't know, and if you're encoding it, maybe it should be shorter, it's a good part. Actually, there are a lot of tools that are saying at some point, more than this amount of bytes in this URL, this is much. A lot of tools are doing that. I don't recommend it, right? Because if you connect to, for example, Google Docs, the URLs are really long. So that's not something that you can call directly. But it's true that in Google Docs, they are not encoding like that.
And this is like GIF at the end.
And there is a GIF at the end. Very nice. Is this a GIF? Maybe yes, right? And also, I like that there are some slashes in there, right? Some slashes, slash, something in the middle. Also, the host in there. Something more is calling your attention in there.
There is word infected all over the place.
Where? What is infected?
If you try search for infected with capital I at the beginning.
Okay, wait. Infected.
Infected, yeah.
Like that.
Yes.
Oh my God. This is it. It's there. Wait infected. You made me remember of once there was, you know, the 1st of April is Fool's Day. So once they proposed a request for common document, an RFC, that they were proposing to add a special bit, 10, to the TCP protocol called the egging bit. And they were proposing that all of the attacks on internet should put this bit in 1. And that's it, right? So if you're not attacking, just put it in 0, and our life will be much easier. And it's an amazing document. You should go there and see. There is an implementation, C code, everything. It's very nice. So you're saying something like that. Hey, it's there. So we're infected. What does it mean? What does it mean? This infected there.
That previously attackers had control of this DNS of this domain name, and right now there is some kind of security service that's gained control of the domain, and to know that it's infected, like the malware string to communicate, it has this header. So it's like we know it's infected. It's connected to it infected.
Okay. Do you agree? Do you concur? No. Yes. I guess.
There is also MIME-type application Octet Stream, and that's strange for the picture, isn't it?
Octet Stream.
And maybe the proxy server in the middle doesn't like it.
So maybe we have a proxy saying, hey, go away.
I see the picture and it's declared as application of that stream. And the picture is not application.
It's
of that
not,
stream
right? Should not.
Until I want to execute it.
Unless. So that is saying, hey, you are trying to download a GIF file, but the content is saying that it's altered bitstream. This is not true for files. So this is weird, right? And what about the infected that he was saying? Is what he's saying okay? What do you think? Like the key word here is not infected, but sinkhole. Actually, sinkhole is not with Z, it is S, right? Sinkhole. What does it mean, sinkhole? I mean, not the real thing, I mean, this sinkhole.
When somebody takes over some botnet, for example, and takes over the domain, as you said, they make the server for it so that nobody can order commands anymore to the botnet. Just they put the server there and the server acts.
Okay, so you agree it's the same and it's completely correct, right? This means that somebody took control of that domain, this one, there, and all the bots that are pre-configured to connect to this domain actually connect to somebody that registered that it's not the attacker. It's this organization, in this case called Sinkhole Project, and they're getting the packets from the bots, and they're answering, hey, yeah, whatever you're asking, okay, this domain is Sinkhole. So, does it mean that we are actually looking at infected traffic or not? Is this normal traffic or infected traffic?
Likely infected.
Likely infected. Can this happen to a normal computer?
Probably not.
Probably not, right? This is weird.
Theoretically can.
Theoretically it can, but yeah. Okay, it's improbable. Okay, he likes it. Yeah, I should be very precise here. No, don't say impossible. So, it's true. This is mostly infected traffic. And question, how is this organization getting control of this domain?
It's word-based GA.
Oh my god, that was very, very good. He said it's word-based DGA. And now you have to explain it, sorry.
Well, all the lanes are pretty long and composed of different words that follow some pattern. So it looks like they have some kind of dictionary, initial dictionary, and by combining the words, they're trying to find the active CNC server.
Okay. Do you got it there? Was clear? No? Do you want him to repeat everything? Okay. So he said, okay, there is a dictionary there, and they are choosing the words from the dictionary, and they are, the malware, when I say there is the bots, it's creating domain names on the fly, in real time, creating new domain names, and just trying to see if they are alive. Like we said about the DGA, do you remember the DGA 2 classes ago? Like the domain generation algorithm that was random, and this is not random, it's word-based. They don't want to put in there .com because that's easy to spot, right? On the side we say that's encoded, not too long, let's kill it. But in this one, actually it looks like a real domain. Declare visioprobatum.com or something like that, right? So actually, yes, this is infected traffic. There are more things to look at here, and this is actually the traffic of Pavel Balak. Where is Pavel Balak? Is here? Pavel Balak? There. So he gave me which was the name of the malware?
1001. The name.
Oh, it was, do you remember?
Yeah, I'm trying to remember.
Usnif. Yeah, Usnif was the name of the malware. So he downloaded this malware the last class, he executed, got this traffic, and this is the real malware that now is working there. So very fast, I will tell you something more. Not all the domains that the malware is asking for are being sinkhole. So actually the malware is working, Some of the domains are being singled, some are not. This means that there is a competition between the botnet and the security organization trying to see who is taking control of the botnet quicker, okay? So, how do they know how to register these domains? How does the organization know how to register these domains? Where is the dictionary? In the malware. So, Veronica found out that the first connection that the malware is doing is actually a thesis of Luther King, and that it's in Latin, and all the domains are created based on that file dictionary that the malware is downloading. This is another good experiment. You can go home, put a proxy between the malware and internet, and when the malware is trying to download this file, you actually feed it with your own dictionary. And then you see if the malware is generating your own domains. That can be very interesting idea. So let's continue. This is what I'm showing this week with Argus. Yeah.
How do the malware or the botnet manage to create such domain names in such a short period of time?
Well, we don't know the period of time. Or what do you mean? Well, okay, it's maybe minutes, yeah.
Well, let's assume that.
Yeah, or seconds.
Pretty quick.
Well, it's really, I don't know. We should open it first. Yeah.
There is obvious that there is some automatization of
yes, completely.
But if the registrator of such domain names sees some traffic like this,
it should be possible. And I think that's what this security organization did. They opened the binary file, they disassembled the instructions, they found the algorithm, and they re-implement it and generate the domains again, right? So they have a list of domains, and they're trying to register them very, very, very fast, sooner than the owner. So whoever is registering first, it's winning. But for doing that, you should know the algorithm. So you should open the binary file, do a reverse engineering, and find it. This is how they're usually doing, right? So only looking at the packets, it's not enough, because the moment you see it, it's maybe too late, right? So you should know which is the next domain that is going to be asked. Sometimes it's time-based, so you know what's going to be asked tomorrow. So that's what you can do, right? Okay, so there is more thing there, a lot of information in here. I don't want to show you everything, but it's a very nice analysis of a malware botnet that we tried last class, analyzed with Argus. For example, look at this flow, right? You have the start time, TCP, source port, destination port, destination IP, destination port. The state, that means that the source connection, the connection going that way from the source, it's having the fin bit, the SYN bit, the push bit, and the ACK bit. The same for the packets going back to the source. And then you have a very, very large download file. 579 packets in one flow. And this is actually a get to a binary file that is an update. So the malware was updating itself. And you can see all of this in just one flow. This is very important for a massive analysis. Okay? So let's go here. Let's do the same, please, with another capture. The capture that is called 2. The capture that is called 2. Do you know what? We didn't put it there, the Twitter hash. Remember? The hash. So, file 2. What you can see there? Come on, analyst. Come on. Take out the analyst from inside yourself. Something like that. I think we are too much used to having the information completely resolved, like reading a blog post about what the malware is doing, which is awesome, but we are not so used to actually creating information. Like, okay, this can be completely gibberish, or can be the best malware ever in the history of humanity. So it's up to you if you discover it, right? You won't believe the amount of people that start analyzing malware and they say, no, this is nothing. And then some other company finds the same malware and publish an amazing report, 5 conference, 6 papers, because they know what to look at. Right? So this is very important.
Well, there's a file called Google Update Setup.exe.
Google is there? Malicious.
No, this looks weird.
Okay, let's see here. Capture 2. There, where? Sorry?
Just search for Google capital G. Update capital
There?
G. No, like Google. No, search for. Yeah, that one.
Which one?
This one.
Update setup X. What is that?
Oh, that's weird.
That is weird. Binary file being downloaded by a computer. What do you think?
Who's the malware? It used to be malware.
Malware.
Yeah.
Binary file is malware. You remember again, Neil, some people in the US that actually they proposed and they did to block all of China just because of China. So, okay, how are we doing business with China? No, we are not doing business with China. That's it, filter China, no control China anymore. That is something similar. X file, forget it, you're out.
What's about the boundary country?
But it's just
Block Czech Republic.
Yeah, I
Who is
can't
doing business with that?
I don't know, I'm using proxies to go
Yeah, absolutely.
to see my accounts.
But it's downloaded from completely weird places.
So it's been downloaded for, okay, this one is being downloaded from here. And what is there? I will search this in virus total or something. So, what is there? Look at this IP. Actually, it's Google Autonomous System. What does it mean? It's connecting to real Google IP and downloading a binary file that is called Google Update Setup. So, let's put some final decision here. Good or bad? Malicious or normal?
Well, there's a URL to the file which can be then downloaded. So
You wanna try?
someone who is brave enough can download it and try.
Somebody with a virtual machine app, can we try please? And that actually is something that a lot of companies are doing actually. Karel is here, yeah, Karel. Karel wants to do, I won't push him, some honey clients that is actually that. Downloading that at the same time that the user is downloading it, running it, and actually seeing it, this is malicious. So if it is, you have something like 10 seconds, go there and block everything, right? So this is something that some people is doing, honey clients, you can search for that. But, so yeah, you can try, look at these, right? And what about this? We are domain name, right? So what do you say? Come on, take your chances here. Malicious or normal? I should go there and block it or allow it. I'm a proxy, can I wait for it? Normal. Who said normal? Normal. There? We can make a pool. This is a very nice way of...
Virus total says it's normal.
Virus total says it's normal. Must be normal. You know, if we are a firewall, and we are taking a decision about one packet, this is going to take a lot of time. The user will be pissed off, right? Okay, so we can continue. When you don't know what's going on, it's a good idea to look for more clues, right? So you have something in there that is suspicious, keep looking. What do you think is going on? The IP is saying this is normal. The domain also. You have an X5 there. You have some Microsoft domains in there. More stuff. stuff. What about this one? Look at this one. What is this? This is inside your long is bad policy.
But this is different.
It's different, right? You can understand it. You can understand the Hebrew here.
This is not that bad. Like I can't say this is bad.
Actually, it's very nice because if I show you only this, you may say it's bad. He's not. But considering the previous information, you say, okay, let me think. The previous was not. So this one, what about this one? Actually, it looks horrible. What about the that slash in the beginning? What about that? Who was putting 2 slashes in there? And more important, look at this. The user agent that is asking for this is Microsoft Crypto API. And what about the host name? What is this host name? OCSPGoDaddy.com.
For certificates.
For certificates, for doing what with certificates? Revocation list, exactly. So actually somebody using the Microsoft Crypto API is asking if some domain that is hosted in GoDaddy, that is using certificates, TLS, was being revoked before, right? So this is a verification, confirmation, and it's actually a normal packet for all your browsers every time you connect to any web page that is using TLS, right? So this is weird, but actually it's normal also. So I will show you some more stuff in there. Just tell me if you have more ideas, okay? I'm scrolling in there. Yeah.
Just search for Skype.
Skype, oh my god. Capital S?
Yes.
Oh my god, what about that?
It's trying to download Skype update and that's weird because first it's trying to resolve getskype.com and it responds with strange domain.
So you have the domain is uiskype.com and then you have something, get latest version, whatever, user agent is Skype, and actually if I continue doing this, there may be more, yeah, there. Skype setup through.x, so what about this? Microsoft servers, she check, Microsoft server, real one. Sorry, that's malicious or not? You can say so, I didn't know. So actually this is Skype updating.
Served by Akamai, right?
Huh?
It's served through Akamai.
Akamai, yeah, Microsoft is using Akamai.
That's why there are those strange addresses.
Exactly, and also if you look at Akamai domains, you don't know if they are malicious or not, because a lot of companies are using Akamai, and also a lot of malware is using Akamai. So you go to VirusTotal, you check, and you have dozens of malware using that IP for malicious purposes, and then you have Skype using it for download, right? So you don't know. So here we have a normal Skype connection. And this is very interesting. This capture is a normal capture of a normal computer every day booting up and working. And there are more X binaries download than the malware one. So downloading X files, it's not an indication of compromise. Actually, connecting to weird domains until you know the reputation, it's not an indication of compromise. So this is why when you go to the network and you try to use some automatic detection tool, you may fail. You may detect these as false positives all the time. So look at this. We have a lot of connections, UDP connections, going to these weird IPs, right? And sending these things in there. So what do you think about these UDP connections to weird ports? 40,022, 40,021, 40,035, sending, I don't know, binary, probably encrypted connections or something that we don't know. What do you think about this?
Those are local connections.
Local connections, why local? because of the source IP? Well, that's the computer that was sending the traffic, yeah. It's going there. So, can anyone check if those IPs or some of these IPs are bad or good by Aristotle? If you look at a lot of UDP packets, short packets, to a lot of IP addresses, which protocol is calling your attention? DNS, it's true, but in this case, the port is not DNS, like,
HTTPS.
HTTP, oh, that was weird, UDP, you are playing with fire there. Actually, he may be correct. I'm not sure if you know, but Google is pushing 2 new standards for HTTP, and one is over UDP. So now you may find your browser doing UDP connections to port 443, downloading stuff, because it's speeding up the connection. So don't panic if you find this in the network, it's real, your Chrome or Chromium browser trying to speed up your connection. So we are not going there, but okay, no. I want to show you, okay, I will go back. Okay, just this one. I want to show you more, but actually there are a lot. These UDP ones, weird ports. Torrent! I like that, sorry.
Video streaming.
Video streaming. Streaming, some streaming. Actually, it's more closer to torrent. Why it's closer to torrent? It is not torrent.
It could be Skype.
Skype! And why Skype is doing this torrent-like behavior? It's peer-to-peer. And peer-to-peer, it's, okay, it doesn't matter, close to torrent enough. So actually, real Skype looks like you are doing peer-to-peer. And actually, you are doing peer-to-peer. So when you connect to Skype, you are generating all these UDP packets all the time. It doesn't matter if you're using it or not, okay? So, these are some of the behaviors we are seeing in these 2 captures. Before we go back to here, I want to say that, yes, I want to say that actually you cannot conclude that the computer is normal or not infected because some connections are normal, right? You should check all of them because a normal computer that gets infected actually is generating normal traffic. So finding normal traffic does not mean it's not infected. But finding infected traffic usually means that the computer is infected, okay? Usually. So, I want to make a break or something. So before making a break, we are going to stop 10 minutes now. We are going to go there. Yes, the interview here. So, in these 10 minutes, I want to do some things. First, remind you of the survey, please. If you have some time, fill it. You can do it now, you can do it next week, I don't care. Don't take the whole week. It's very important for us so we know how to continue this. We want to continue, we want to know if it was useful, it was not useful, what you want to change. So it's very important that you tell us what you think about it, right? So that is the survey, or also there you have the same survey. And in there, I have, it's Stanislav Novacek here. Is it here? There! We have a prize for you. Wait for it. We have a prize. Because, wait for it. There. Ta-da! Because it has the nicer report of the first class, so welcome him with an applause. There you go, glad to do it. It was very nice first report, I like it. And also, right now, I want to thank my angels. So I have something for you, angels. I have something for you. Ta-da! So thank you much. This is for you. Thank you. It was very happy to have you here. No. Sorry, it's not. So that was the thank you. So we are going to stop 10 minutes and we continue, okay?
Yeah. That's okay. I imagine very few papers before.
Perfect. But I am really happy that we made it to through the project.
Yeah, I'm really happy. Thank you very much for working. So I'm so happy that you were talking so yeah. Okay, forget it. Okay. But was really so
5:30.
I hope your email was not saying send the paper tonight.
No. I hope it wasn't too rude. I tried to write it like, well, students postpone it to the other day, but send it as fast as you can, but, it's okay.
So that's why I say, okay, within the weekend we can finish it. We are going to Gara tomorrow and Saturday. So I say, okay, we can do it Saturday.
I just learned that my writing is quite free. Because they're on the go by car. From going there for training.
Yeah, sure.
I'm quite sure it's not, so I bet very expensive my blind. It's doable. You need to cooperate.
Last Saturday we were to weekend, Easter and Saturday we took 2 hours to our and then we smoked like 4 hours. On Sunday we woke up at 20
paper done.
We needed
dancing and we've been together with people who are like street they're not used to somebody who takes child to the market, right?
but otherwise
But I can say realistically, and then I can ask just
sleeping my brother.
okay, because of how old
Night after as well, right? Just
just more than what's here. Yeah, he told me. It's very sure. So it's not mature, right? So it's like, he doesn't have a demo. Probably was doing it, making it. That's
the day before, the day after, we've seen how it looks like that she's a compare it.
yeah, me too.
I tried to convince my colleague and my friends to be here today. It's quite a shame, but never mind. But we had a perfect idea. If you will ever think about it, let's see.
Yeah, I think I didn't sleep 14 hours.
Just okay. It's from the nights.
Yeah. You can, you do it. It's okay. Yeah. Hi.
Just a quick one. You got the same.
Like, you're calling?
I'm calling.
Yeah. And when you do this, it's not turning on.
And when I out, it's still.
Oh, yeah, okay. Yeah, it happened the same last week. I know, I can tell you. I have an answer. Don't worry, it's for you. So, look at this. You have the same problem. And this is called floor. This.
Oh man.
So, yeah, look at this. Yeah, the same problem. So, the sensor is detecting that you're still talking. And if you do this, it's putting you as you didn't notice this.
Really?
When you showed me, I saw that here it's very close and here is black.
Now I know.
That's it.
Man, you're a wizard.
I'm sorry. It's amazing. The sensor hit the floor and have the same problem in the same corner.
Never.
Really?
Never. So it's
Girlfriend.
same place.
Simply. Well, I know this is
They've
like,
got like.
oh yeah, maybe yeah. But this happened to me like 1 week ago. I was at home. I great vision of the and I was at home, and one day I was doing me this issue, and then looking at it and saying, oh look, what's going on here? And Veronica pushed it.
Man. Now I see.
Yeah, now I see. You can change it, but I think
It's still.
yeah, the price of it. I think, yeah. Oh, it's very good to go there. There is a Sony shop.
I've got this show.
What So, coming from now, sorry about that.
Thanks for first. Yeah, planning with the problem.
It's okay. Okay, shall we? Not sure about the time actually. Shall we continue? Are we all here? People in the hallway? Welcome. Also, I remember something more. Remember that after today, we are going to an after party. After party. So we have a reservation. Yeah, can you later put yeah, it's in the mailing list. The address of the place. I'm not sure if you remember the. How was the name of the place? This nice soldier that you have in here. Yeah, this one. I don't know how to pronounce it. Ah. So we're going there, it's close here, 2 blocks away. We have a reservation. So after the class, we are walking there. Okay? Like tourists. It's about 30, so it's okay. We have a lot of places there. So if you don't want to go and you didn't tell me, just go. Okay? So let's continue. No, not anymore. So I want to tell you about now how we are dealing with this issue with the Stratosphere project. And for this, I will have to talk more because until we get to the point that you can try it, I want to explain you how we are working in Stratosphere. So, bear with me now, it's going to be more talking on it for some minutes. So, Stratosphere IPS project. Very quickly, I will tell you the Stratosphere is a free software project, so we believe that this tool should be free software. Not only free, as in free beer, but in freedom. And this project is a behavioral IPS, so it's an IDS, intrusion detection system, intrusion prevention system, that is based on behavior, not content, but behavior, and it's using machine learning for detecting these malicious behaviors. Okay? So, what are we doing here? The first thing we are doing in Stratosphere is that we are taking the flows. Remember that we were having packets first. These are packets, and we were converting these to flows. Okay? Remember the flows? Are these flows? So in Stratosphere, we are taking one step further. We are aggregating flows, okay? Aggregating flows. So actually, we get all the flows and we create what we call a connection. Connection. Sometimes we call it a 4 tuple because it's actually made of 4 parts.
So why are we aggregating connections? Because if we are only able to detect one flow, imagine that, I don't know, he's connecting to Gmail, okay? So he's going to Gmail, checking his email, and then nothing, because he's doing nothing between email. And then one day later, he's again checking email, and one day after that, again checking email. So if you're only looking at his flows to Google Gmail, you will have one flow per day. And one flow per day is not enough for most detections. What we want is his behavior to Google Gmail independently of the time frame. So if he's sending one flow per day, I don't care. I want to know that he's doing that each day, okay? So for doing that, I'm taking all the flows and I'm aggregating them, forgetting the source port. So take the source IP, destination port and protocol, and aggregate all the flows together, okay? What does it mean forget the source port? It means that every time that he's making a new connection, therefore the source port is changing, I don't care about that change. So every time his computer, source IP, is connecting to Google, destination IP, for Gmail, port 80 or port 443 in TCP, I want to have all these flows together, okay? Do you follow what I'm doing here? Very simple, all the flows to the same service together. So we say that one connection is actually the behavior of one computer to one service, in this case, Google Gmail, okay? So we are doing this and we end up with this connection, and one connection is actually a group of flows. Okay? So we just take all the flows and we aggregate inside one connection. So then for each flow in that connection, one flow, we are extracting 3 features: duration of the flow, size of the flow, and periodicity of the flow. And why only 3 features? Usually if you're doing machine learning, it's very common to extract 3,000 features. Or more, right? The more features, the merrier. The problem is that that type of machine learning will create a very complex model, probably, and very complex models have the issue that if they don't work, you don't know why. Worst, if they do work, you don't know why. So it's very difficult to deal with this. So you create amazing model, because we start there, everyone's starting there. I want a very complex model full of stuff in there, you run it, there is some result, and you don't know. And then you want to verify, impossible to go back. Where is the error? Forget about it. So after some time, we learned and we went back and we select a very small but very useful set of features: duration, size, and periodicity. So, duration and size are straightforward, okay? You know what I'm talking about. But what about periodicity? So this is periodicity for us. Each researcher is thinking about periodicity in a different way, okay? So this is very important. Usually when you read about periodicity, you read about Fourier transformation, right? You know about this, you can do it right there, right? Fast Fourier transformation, easy peasy. Now, so we are not going there. We want something simpler. And this is like this: one flow, another flow, another flow, another flow. Start time or arrival time: 10, 10, 20, 10, 40, 11, 11, 05. So we first take what we call the first time difference. First time difference between these 2 flows: 20 minutes, 20 minutes, 20 minutes, 5 minutes. And then we take the second level time difference. So between 20 minutes and 20 minutes, actually it's 0 minutes. And then we say that these 3 flows were periodic. And then between these, we say, okay, 20 and 20, 0, okay, this is periodic. and between 20 and 5, we say, hey, 15 minutes. No, maybe not. Okay? You got the basic idea? Actually, we are not doing this anymore. We are not. This is like the difference, 20 less 20, 0. We are not doing this anymore. We are making a division, 20 divided 20, and we get a 1. I'm not going to go into the details why. Just have in mind that this is what we are doing, okay? Second level time difference. That's for us a periodicity. So, I'm not saying that all the connection is periodic. That's actually not true. I'm saying that these 3 flows are periodic or not, and then these 3 are periodic or not, and this is. So I'm saying at each moment if there is some periodic behavior or not, because the connections are changing all the time. Okay? So there is no such a thing as an only periodic and only non-periodic connection. All the connections at some point, Google, Twitter, whatever, are periodic, and then they are not periodic anymore. Okay? So this is giving us a very nice idea in each moment how is the behavior of the flow. So then we get these 3 features: the size, the duration, and the periodicity, and we discreticize them. So we take the numerical range and we put some thresholds, and we say less than this threshold, I will consider it small. Between this threshold and this one, I will consider this medium. More than this one, large. Okay? So we go from a feature that is numerical, the quality is in the numbers, to a categorical feature. Okay? Of course, here we are losing a lot of information. Actually, a lot. You may ask how much. Well, we hope that we are not losing so much that the method will work. Actually, for us, it's working. So we believe that what we are losing is not so much. Of course, we can make it better. Yeah, maybe it can be better. And that's something for future research. So far, this is enough. So, the size can be small, medium, and large. The duration can be short, medium, and long. And the periodicity can be no data. What means no data? I don't have 3 flows yet. Because remember, I need 3 flows. So if you only have 1, you don't have enough data. So you're here. And then you have strong non-periodicity, like you are way, way far away. Actually, weak non-periodicity. You are not periodic, but you are actually very close. And then you have a weak periodicity. Okay, you are periodic, but not so stable. And the strong periodicity is like completely automatic stuff. Okay? So based on these separations, we are assigning letters. And so if you have a flow with small size, short duration, and strong periodicity, you will get an A, or a B, capital B, or an S, or a T, or a number. Okay? We are converting the flows to features, the features to letters. Why are we using letters?
To classify.
Well, yes, at the end, yes, but why letters and not, I don't know, numbers between 100 and 11,000? I don't know. Why are we choosing letters for representing this type of information?
Human readability?
Exactly. We need humans to verify this. Because we had this problem in the past. You see the data, and then you want to verify. Is it working? Or better, is this connection malicious? I have no idea, actually. I don't know, call some expert, right? So these letters allow us to say, hey, wait. These are letters. I can read letters. So what is this? A, B, B, A, B, C, C. Ah, okay. And what is this one? X, X, Z, Z, Z. So with just looking at these, somebody can verify if there is some change, behavior, not behavior, if it's the same, if this is working, not working. Because remember that we need humans to check this at the end, right? So, yeah.
Have you tried some other visualization, like something even more graphical?
More graphical than no letters or with letters?
No letters.
Polar
images.
Well, images. Somebody was proposing the weird matrix symbols, but it's weird. Oh yeah, you can do it. Actually, you can do it. The thing for me is, if a human can still look at this, I like it. For example, images, it's a very nice idea. Because you can say, okay, colors, right? Colors or shades. So we have some research that we want to transform that to images and videos later. So it's like with the letters, do some image, like 50 by 50 or 80 by 80. And when we have this matrix that looks like some image, actually you can implement methods for image recognition, like neural network.
Well, I meant more like plotting.
Or plotting, yeah, completely. It's completely true. But we are not doing it like in complete research. It's just idea. If you like it. Okay. We will love some experiments. But it's true that if you convert these to images, and the images are moving, you have videos, and there are a lot of stuff for you working there. Okay, so let's continue. Also, we are assigning some symbols between the letters to give us some idea about the timing, because periodicity can be one flow each year, right? That is periodicity, or can be one flow each second, and this is completely different behavior. So we are using some samples in the middle to say, okay, the timing is between 0 and 5, 5 and 1 minute, 1 minute and 5 minutes, 5 minutes and 1 hour, it's a star, more than 1 hour, just put a 0, okay? So you will find some letters and some symbols in there, okay? This is our behavioral representation. It's not the only one out there, it's not the best one maybe, but it's the one that is working for us. And it's working so well actually that the research we are doing is only based on analyzing these letters. So our algorithms are not looking at the traffic anymore. Actually, I don't care. You give me the letters, I can do it. And this is also nice for the aggregation of traffic, because imagine that we are having one connection, and for each flow we are putting a letter. So imagine storing this. Letters can be compressed very easily, so you can store a lot of traffic like this, okay? So, let's move a little bit more. I won't tell you about the threshold, but this should be trained. So we spend a lot of time training the threshold to have a good detection. And here is, for example, how one of the behaviors may look like, okay? So this is a behavior of one connection, and you can see that there are some numbers at the beginning because you don't have enough data. And then you have, okay, no periodic, and remember the comma means between 5 seconds and 60 seconds, right? And then you have another flow that was periodic, also periodic, but for example in the D, it means that you change from a small size to a medium size, so you went from an A to a D, okay? So you can see the behavior like that. Let me see if I can show you some image in here. Wait for it. I want to show you some image. Wait for it. Wait for it. So okay, it doesn't matter. I will show you later. It was just putting these letters in the traffic. Okay, so how now working on this, we can use different algorithms to detect this, right? So, for example, we are using Markov chains. That's what I'm going to show you. But there are some works doing neural network, clustering maybe, DNA, because these are letters, right? DNA is also letters. So maybe some DNA analysis techniques can be used in here, right? Also open for research. So let's try it, okay? Let's try this. Where are you? Here. So please go there and clone that Git repository. So let's try this, git clone that URL, and let's try to use it. What you are downloading is what we call the testing framework, and it's only for research. There you go. Oh, you already have data in there. Very nice. Okay? Cloning. So first clone it, then get in. Please remember to check out the develop branch. If you don't know what Git is, just ask, we can go into it. We are not. Remember to check out the development branch. Then please install all these libraries, because without those libraries it's not going to work. And then get inside the folder before doing the /stf.p. Come on, you're not gonna clone it. Okay, remember the branch. Remember, not the master one, okay? Ready there? Is it running? No? It's not? Okay, so I will move a little bit. Oh, come on. There. So if you're running it, you should see something like this, okay? If it's not there, wait for it. Yes, it's oh, okay. Wait for it. Wait for it. Why not? Why not? Show not here. It's not. Can you please? Sorry, I have to look up here. Oh, there. Oh, there we go. Sorry, I don't know what happened. Can you look at it? So you should see something like that. Okay? This is, for example, this is the console of Stratosphere. Okay? So, Stratosphere testing framework is a framework for testing algorithms to detect the behavior in the network. So this is a Python console, you can type in there, you have auto-completion with tabs, so you have some other commands in there. For example, you can use the one that is datasets, -h, and you will have the help for that command. So in each command you have the help in there. I will show you just some of them so we can continue, okay? You can try it more later. So the first thing we will do is we will create a new data set reading the pickup file, okay? Reading the pickup file. So you will something like that. Yeah, it will be something like this. Datasets -c capture one.pickup, and you will create a dataset. Okay? So with this command, you create a dataset in the system. When the dataset is created, it will give you an ID. This is the ID we will work from now on. Okay? So once you have your dataset in there, what we are going to do, for example, here I'm using dataset 109. You will create the Argus flows using the -g parameter, okay? So you first import the pickup, then -g, you create the Argus flows for that pickup, and actually those are two new files that are going to be stored in the folder where the pickup is, okay? Are we there? No? You need more time? Error. From the 14 per parts. Wait. No, you need to call the utility. You need to install that one called the utility. Try to install all the libraries that were there, did you? Okay, you're in Kali?
No.
Sorry, no support for our operating system. Okay, you need the day2d library from Python. Okay, Python day2d.
We installed that and we still have an error. We are not in Kali in about SODB.
SODB, import, also install SODB. Did you?
Yeah. And it throws an error saying SODB pickle.
Sorry?
SODB pickle is not cannot be imported.
I don't know. Should work. Just be sure, in SODB there are a lot of different libraries. So make sure that you install all of them, because Kali already has some of them. So maybe you need to install some other part of the SODB. Okay? SODB is a database for Python objects and no SQL database. We are not going there anymore. Okay, so from there, if you generate the files, now we can generate the connections. So with the command connections-g, you generate the connections for that pickup file. Okay? There, he has the connection. Some connections in there. Some connections in there. Very nice. Some connections. Working. Okay. So, let's move. We have the connections in there. You can see the connections with the connections. Actually, I have to select dataset 109, and then you can see the connections in there and say, hey, actually, you have this amount of connections in there, and I can list the connections in there with capital L and the ID of the dataset, and you can see each for tuple. Remember what I said about the for tuple? So this is the name of the connection. It's source IP, destination port, protocol. And then the number of flows inside that connection. This means we have a lot of connections, ICMP, UDP, with 1, 2, 3 flows, and then we have one with 12 flows in there, 3, something more, 2, 8, 9, 10. Okay, you're looking at the other capture, right? So I should do this. Wait for it. Data set 108. Oh. And I should do what about this? You're looking at something like this, right? Or not?
Just a quick question.
Yeah.
Where should be Argus installed? In which folder?
Argus, sorry?
In which folder substance to receive it?
Is looking in the system. So if you should do Argus in any part, enter and should be working. If you can do that, it will find it. Okay? So I will show you again 109. Oh, come on. Oh. 109. Okay? So you will see the connections and then you will see the number of flows in there. Okay? Do you follow? So now we can actually create the behavioral models of letters with the command models-g. So we want the letters in here. So please do models-g, and then you can look at the models with capital models, capital L, the ID, and please remember to put -1 after the ID of the dataset. Why we are doing this? It means dataset 0, for example, so the models should be 0-1. It means for the dataset 0, the first version of the letters, because this is an experimental framework and the people can create new models of letters all the time. So we are going to use the number 1, okay? So it's something like this. So models, you can see the models in there, and then you can see, sorry, data set, that one, right? And then you can say, okay, give me the dataset ID 109-1, and here you can see the model of letters, okay? So look at this. These are the models of the malware we were analyzing in Capture 1. This is the ursnif botnet that Pavel was executing, right? So look at these connections, and each connection is having a letter. For example, E. Was E periodic or not? It was. And what about the star? What does it mean, the star? So E was periodic, and the star means between 5 minutes and 1 hour. So this means that these connections were sending very periodic flows between 5 minutes and 1 hour. That's a lot. One question: why do we have this amount of connections? Because if you remember correctly, these connections were for this DGA domain, right? You didn't notice at that time, but we were looking at the domain that was the same domain. But if you were looking at the IP address was changing all the time. So this is allowing you to see another behavior. Oh, look at this. Actually, there are a lot of IPs here, and each IP was not getting more than 5 or 6 flows. This is very interesting behavior. It's not just one IP. It's a group of IP getting the same behavior to the same port. And this is usually not normal. And what about this one? Look at this. Very long behavior of letters. Some are periodic, some are not periodic, and then we have these zeros. The zeros mean 1 hour timeout per zero. So actually it was not sending stuff for 1, 2, 3, 4, 5, 6, 7 hours and then start sending stuff again. So this type of behavior is not possible to capture if you are not looking at the long-term behavior. So here you can see there is some periodic stuff, no periodic, periodic, no periodic, and then something that was not sending for 3 hours, then sending again, and you have some large connection. Actually, you have one connection here, and you have one connection here, and you have one connection here, 3 connections with very long and large amount of letters. 3, but the rest is very short. This is giving you an idea. If you have to go there and shoot down the botnet, where are you going to go? Well, I will go to these 3 IP addresses. They seem much more important than the rest. Okay? Other thing, look at this behavior here. What is that? Periodic and 1 hour timeout. So, flows that are more than 1 hour between them and very periodic. Actually, wow, no error, no loss of periodicity. Wow, this is like very good. What is it? ARP, right? So this is automatic connection from the operating system just using ARP, like normally. So this is telling us something very important, and is one of the first things we learned in the Stratosphere project. Botnets, command and control channels are periodic, but not perfectly periodic. They are not completely periodic. This is a command and control. Periodic, somehow, yes, down, up, down. The perfect periodicity is only coming from automatic tools from the operating system, like ICMP, ping, IRP, stuff like this. So if you see something that is perfectly periodic, that's not malware for me. It's, I don't know, some tool, somebody left a tool running, whatever, right? So if the botnet is doing something interesting, at some point it's losing periodicity. Maybe not, this is not the rule, right? But it's very important behavior. Okay, so we have the letters in there, okay? A lot of letters, You can see here also very automatic IPv6 resolution. This is the same as ILP but in IPv6, it doesn't matter. And then we have some ICMP, we don't care about, very short ones, right? And then you have some, we can say, what about this? Some behaviors are with the E, and some behaviors are with the B. Are they the same? Are they different? So, let's find out. You can do this actually, look at this. I will select one of the connections that is doing the EE. I will copy it. You can get outside of this with Q, because this is a pager. And then you can do this. Connections, dash, capital F, and the ID of the connection, okay? So if you do that, you can actually look inside the flows. And this is speeding up the analysis very fast. So from inside Stratosphere, you can go to the flows, check what's in there, and go back. You don't have to leave it there. You don't have to open TCP down, Wireshark, nothing. Just say, okay, what is this? Go there, connection. Oh, look at this. I can look inside the flows. And actually, these are the get images with the weird thing in there. And the response, where is the response? Here, here, the response was 200 OK. Okay? So, response 200 OK was generating the E letters. E letters. Okay? Do you follow me? So, now look at this. I will again look at the models. And I will get some of the models that are getting the Ds, like this one. I will copy it, and then I will say, show me the other one. And what about this one? What is the difference?
Different domain.
Different domain.
No response.
No response. So this was an attempt to connect to a command and control server, and the server was down. The domain had an IP, but the IP was not answering. Look at this. Hey, I'm sending you the flow here. Look at the state. The state is SYN packet, nothing. SYN packet, nothing. I send the SYN packet, nothing. SYN packet, nothing. And the timing is different. Now it's getting a beat. In here you have the first level time difference between the first and second flow, 6 minutes 40 seconds. Between the second flow and the third flow, 6 minutes 40 seconds. And the division between these two numbers is giving you 1.000. It means very, very early. If we are going to the other one, actually it was sending the same periodicity, but the difference was in the size and in the duration. So look at this, size 1040, 023. This one, size 194. So, only looking at the letters B or E, in this case, we can differentiate a command and control that is working and it's up, and a command and control that is down. And this is very interesting differentiation. So far, if you look at the detections out there, they are detecting a command and control or not. But in this case, we are going to detect a command and control that is working from a command and control that is not working. And that is also interesting for the blocking, okay? So, let's continue here. There. We have the behaviors. Yes, we did that. Also, I want to show you the visualization, okay? So, you can do this. Visualize. I will ask the help in here. So, it will be 109. And this command called visualize will show, oh, that was very fast. Actually, the behavior of the letters, let me show you again, but faster. The behavior of the letters, this is too, okay, maybe there. How they are happening letter by letter, okay? Okay, I will speed it up because the timings are different, right? So I will say, oh no, sorry, like that, or there. So you can see how the letters are being asked in sequence, right? So look at this. There you have the big one, some other command and controls, some there, some there. After some time out, it continues, then stop. It's connecting new domains, new IPs. Let's see if it's continuing there, another one. So actually, you can see the dynamics of the connection. It's not being asked all at the same time. It's sending some flows, then going to another IP, going back to this IP, going back to another one. This is the behavior of the malware. This is where the human creating the malware is putting some behavior, and that's why it's interesting to detect. Okay? So that's an example of it's not so good as the visualization that they want to do on RAM with matrix, but you can see the letters, so something is in there.
I think the UI is broke.
Sorry?
I think the UI is broke because you can.
Yeah. When the visualization finish, usually it's not coming back, so you should Control C.
Yeah.
And then you are not going to see, but you have to do exclamation mark reset. This one. Type that, even if you're looking. Sorry, the module is broken. Beta, I said it was beta. Actually, I don't know how to fix that in Python. If you know how to do that, because it's using N courses, you know the N courses? So if you know how to fix that, please send an email. I have no idea. So let's go back to our detection. So what are we doing with this? Okay, we have the letters. What we can do? I will tell you about one detection: Markov chains. Do you know Markov chains? Yeah, someone there, Markov chains? No, there, yes, kind of. Markov who? There, I remember some professor talking about this. I remember a professor saying, remember, Markov chains are... So, very, very fast, what are Markov chains? We are looking at the letters and we are analyzing the transition from one letter to the next one. Okay? Transition from one letter to the next one. Markov chains. Yeah, this is what I want. So, something like this. This is so slow. So, what we are doing is, okay, we have the letters. You should look at the transition from R to R, R to R, R to S to S, and compute the frequency. So, how many times are you going from R to S, from S to S, from S to R? And from the frequencies, compute the probability. So you end up saying, okay, given this amount of letters, the probability of going from R to S is 0.2, and the probability of going from R to R is 0.8, and the probability of going from S to S is 0.9. Okay? So this is two letters and a graph showing the probability transitions of going from S to R, S to R to S, and S to S, and R to R. Okay? So based on this probability, you can actually generate letters. Or from the letters, what we are doing is generating the probability. Okay? Got it? Very crash course on Markov chain. Please read about this. There is more. Okay? Are we here? So, what are we doing with this? What are we doing with this? We are creating the Markov chain representation. So, we get the letters, we create the Markov chain, the probability transition, we store actually on disk, and then we assign some thread call, like, okay, if you are similar to this probability transition network, if you are similar to these letters in 99%, I will consider that you are the same. If you are similar more than 80, you are the same. You put the thread code in there. Actually, we put it there, but it's training. So once you have how similar these letters should be, we are going to another network, a known network, with the letters we know are from a botnet, and we are trying to find similar traffic. Okay? So again, I'm looking at the botnet behavior. I know it's botnet because I saw it. I create the letters. I learn the probability distribution of these letters as a Markov chain, and I go to another network. I see the traffic. I don't know what's this traffic, but I can generate the letters from the unknown traffic, the letters, and then I got these letters, unknown letters, and I say, hey, which is the probability that this model that I know it's malware generated these letters? And this is a number. And you say, okay, you know, the probability that this, whatever you are giving me, was generated by this model is 99%. Okay, good enough. I will say that if this is malicious, then this is malicious. You follow me? Questions? No? This is important part? Okay?
How many false positives do you see? How do you know the traffic?
That's a very interesting question, and it's very difficult to measure, because it depends on the normal traffic. So if you're going to a network, you can try it and it's no false positive. Oh, you say this is awesome. And then you go to another network and then you have 1 positive per hour. And then you go to another network that for some reason it's having similar behavior and you have 1 false positive, I don't know, per every 15 minutes. So in our experience, our models running in the university are giving something like 6 to 8 false, maybe 10 false positives, 8 false positive every 5 minutes, 10 minutes, right? From 3,000 hosts. So actually, it's a lot of traffic, and for us, it's enough errors that we can check manually. Actually, I can look at 10, 15 errors, and then I say, okay, what about this? Oh, this is true, this is false positive, this is true negative. So this is what we want. There are errors. Yes, there are. It's impossible not to have errors. The thing is, can you analyze those errors? So if you have so much errors that nobody can look at it and nobody can verify, it's impossible. If you have something that you can manage, hey, it's okay.
But it depends on how strong is better.
It depends. How good is the original model? On the thresholds you have in there, and also depends how you are doing the verification. Because if you are only getting traffic every 5 minutes, it's not the same like every 1 year, right? So that is something you should learn to say, okay, in this moment I can look at this. More than this, it's alright. And he's right. Some models are so bad that they are matching everything. So yeah, maybe it's a bottleneck, but come on, this is not working. So that's the work of the analyst, saying not all the models are the same. That's why Stratosphere testing framework to test, to say, okay, that's why we are putting a lot of data sets. So give me data sets, I will run all my models, and then I will tell you the final result. Okay, this model is good, this one is not so good, this one, be careful. How are we controlling that? With a threshold. So if I have a model that is bad model, I will give a very high threshold. So you have to be very, very, very similar for having an alert. And if the model is very precise and good, I can give you a smaller threshold and I will get very nice results faster. Right? Okay, so let's try to do it. Let's try to do it. We are on time, kind of. So let's first assign a level to this. Okay? Let's first assign a level to this. So, actually, I will wait for it. Where am I here? No. Okay, yes, here. Wait for it. I want to show you. I want to show you data sets to L. Okay, doesn't matter. Okay, how do we put levels in here? So, it's very important to put the labels. Without labels, we don't have detection. So, if we don't know these normal or malicious, no detection. Okay? So, how do we put labels? We get the label command, just like this, and we say, add a new label. The label is for this connection, and it's belonging to this tuple. Okay? The 0 data set. Models 1. So you can do this. Oh. There we go. Right? And you can, in this case, 0. And it's going to tell you if you can assign a level there. Now it's reading all the levels and saying, okay, hey, this connection already has a level. I will delete it because I put it before, right? So just delete 6655, So assign it again, and it's saying, okay, do you want to add a new label here? Okay, yes, I want to add a new one. So enter, and look at this. The label is not automatic. It's asking you, okay, where is this connection coming from? Is from something, like from the botnet, or it's to the botnet, because it's not the same. No, this one was coming from the botnet. So you actually put here from. Okay, and now it's coming from a botnet, malware, it's normal, it's an attack, it's background. No, this is a botnet, I know about this. And which protocol is here? So we know that the protocol here is TCP, so you have to put TCP in there. Okay, I'm not sure what I did. TCP, there. And then it's saying, and which is the topmost protocol of this connection. And for this, you have to go inside, okay? So, okay, no. I was analyzing this because remember, you're the expert here. So for the label, you should know what's going on. I don't care how do you know, but you should know. So this is actually HTTP. Oh, sorry, I messed it up completely. So again, did you see what happened there? I put it wrong, and it was saying, I cannot assign the label. Why we are doing this like this strict control? Because the labels are so important that if you put them incorrectly, it's not going to work. You are going to have a lot of errors because you put the label incorrectly. So we are doing this step by step, so you are very sure of what you are putting there, and you are not just copy-pasting some label in there, okay? So I would say that this is a command and control, and that's it, right? So from there, it's saying, okay, we have more labels that look similar to what you did, and I would say, no, it's okay, I want a new one. These are not my labels, I want a new label here, okay? So it's going to assign a label in such a way that if you go back to the behaviors, if you go back to the models, at some point you will see the label in there, okay? So you say, okay, this is one of the labels that you put in the connection, okay? So, yeah.
You were creating the label. You were saying from, bonnet, and to bonnet. What it means?
It means
because when you referenced the flow or the connection, it was first the source IP and the destination.
It means from, because I know that the infected machine was this one and it was generating the traffic. So the source IP was generating the connection to the outside and making the command and control channel. So
from the bot.
From the botnet. From botnet, a TCP connection HTTP.
And what is to?
To the botnet, because somebody can connect to the bot and do something that is also malicious. So if the connection is coming to the bot, you should say that it's going there and not from. And why are we doing this difference? Why do we care about from and to?
Maybe we are not infected yet.
Could be, but especially because any computer like your computer there, it's right now receiving a lot of connections. But if you're analyzing all the packets with his IP address as packets that he generated, you are mistaken, because there will be a lot of packets with his IP address that he did not generate. For example, if he's scanning his computer, you will see a lot of packets from the port scan with his IP, but he's not doing them. So you cannot evaluate those connections coming to him, just because his IP address is there. So, because the IP address is in the network doesn't mean anything, except if he is generating the connection. Okay? So that's why we say, no, this connection is awesome, but it's coming from the botnet. This is okay. This connection is not coming from the botnet. This is actually coming to the botnet. So the behavior is different here. Okay? In practice, most of the time it's coming from the botnet because that's what we care about. We don't care about what is going to the botnet. Okay? Yes?
Why do you care what is actually going to botnet?
Why? Why do you not care? Or do you?
Well, that's what I'm asking. Why?
Ah, come on. Why? Okay, somebody, why? Why do we don't care what's going to the computer? No, not that we don't care. We don't care so much.
Because it was not originated in the computer, and we cannot do anything with it if it's not in our network.
For example, so if he is sending a malicious binary file, completely horrible, to him, but his port is closed, and say, no, I don't care. You will see this traffic completely malicious. You go to Snort, and Snort is saying, oh my god, malicious, and you see his IP there. You cannot think that he's responsible for that, because he's not generating, he's just receiving it. So, it's okay to care what you're getting, but it's not the behavior of the user, it's the behavior of the rest of the people there. So that's why it's very important to say, no, I don't care about everything, just I care about what you generate. And that's why in the flows, it's very important the state. Because with the state, you can know if this is established connection. So, for example, if he's sending packets to him and UDP packets, and the port in UDP is closed, he's generating an ICMP packet to him. So if you don't match this, you can think that he's actually sending ping-like packets to him. And say, what is this behavior? We are connection suspicious, just erase his computer. So at some point, it's better to just recognize the difference, okay? Okay, let's go. We just put the label in there, so we say, hey, from botnet, TCP, HTTP, this is a command and control is down in this case, and then we have another label there. I put from botnet, TCP, HTTP, command and control long, because this is a long one, okay? And then we have here the last one I just put. The last one I just put from botnet, TCP, CCC. Actually, this was the up one, okay? So we have some labels in there, okay? Let's continue. Labels in there. Now that we have the label, now that we have this label, we can create the Markov chain model, okay? So for this is very simple. You just do, where is the command? Did I put it? Did I miss it? Oh my god. It's not here? Oh my god. Okay. Sorry. So it's actually generate and the label, for example, like that. No, I mistake. This one. Oh, can you please? There you go. Okay? So Markov models 1, and you can see here generate. Okay? So we are going to generate the Markov model, Markov chain for this label. So let's do it, okay? I will copy this, I will go here, oh, there, I will copy it, it's going to tell me 13, there we go. So we create a model with the ID 231. Let's look at the models, look at this, Markov models 1-L. So in here, we have all the Markov models we just created for that label with the behavior, okay? So this is the transition matrix for that behavior. Okay? Yes? Now that we have a transition matrix, I have to say how much I trust this behavior. So this means I should put a threshold. I should put a threshold there. We are going to make this very, very simple. I will add the threshold 1.1. That is the smaller threshold I can put. It means I trust this model a lot. Actually, this should be trained, and there's a module for training. But this is a fast way of saying, okay, I will assign you a very nice trust in you, okay? 1.1, and was then, I. And if you look at the models now, you will see that this model now has the threshold 1.1, okay? So what I want you to have in mind is, we create the model letters, we create the Markov chain here, we have the threshold, we are ready to export this to the hard disk, okay? So we are ready to export this and use it in another network. For that, it's here. For that, it's just exporting the models. Okay? Okay? I know I'm going a little bit fast here, I'm sorry, but I want to show you. Huh?
How many models do you have so far?
Difficult question. I think that we have now something like 500 or something. Yeah. We don't use them for detection all the time. So we are using something like in 2013 that we know they are working very well. The rest we still don't know because we lack testing, right? We like more interaction in there. So we have them, they are working, but we don't know how good they are.
So you are like testing the threshold, changing the numbers and so on.
Exactly. We train them and then we go and test, right? But during the training, you can select these. Okay, I have 40 data sets that are normal, 40 that are malware, botnet. Tell me how good you are detecting these, and the training module is assigning the threshold automatically. Okay, with this model things, this error, false positive, false negative, the best threshold for you is 1.98 or something. Okay? So that's what is usually what should happen. Okay? So we are going to export this and say, hey, Markov models 1, export this one and just export them to the TMP folder. Okay? So right now there is a file in there. There is a file in there, right, that is having the information on how to detect that model. Okay? So let's see now how we can work with this. And for working with this, we are going to use a software that is called Stratosphere Linux IPS. Oh, sorry about that. Stratosphere Linux IPS. Okay? This is the Linux version. There is a Windows version that František is doing there. So if you have any issue with the Windows version, hey, you can call František. He's actually not developing in Windows. He's fighting with Windows. Horrible. So the idea is to have the Linux version and the Windows version. And this software is only for reading the models and apply them in a new network. Okay? So I would like you to try that. We are very short in time, so let me show you, and then you can try it later. Okay? So, what should we do? You can, if you can follow it, you can still do it. It's just very similar to what we did before. What we can do with this is the following. sorry about that, right? So using the developer version, remember all what we are doing is in this version. What we are going to use, this, what I'm going to use is, oh, okay, I will show you, I will show you the same capture that we were doing with you, and that is called in this case free. So this file here, this file, right, is the same pickup that you have in there, okay? So this is the URF sniff botnet that Pavel was executing, okay? So what I'm gonna do is it's gonna read this file, look at this. I'm gonna read this pickup file, I'm gonna run Argus on it, I'm gonna get the flows. So far here, let me show you. So far here, it's failing. So wait for it. There we go. No, here. So far here is just flows, okay? Just flows, okay? The same thing we got before, just the flows in there. So now I can say, actually it was correct before, sorry, but I mistake the folder. So actually I can say, get this information and execute the sleep program in there, okay? So let me show you. Oh, yeah, of course. Sorry. This is the problem of not following the document. I want to show you the assets, scenarios, yes, status set from capture, and here is free. There we go. So if you look at here, okay, that was too much. There, that's too much. Protection. There we go. Okay, so I'm just reading the flows, like reading the flow from the network, and on these flows, I'm just running the Stratosphere Linux IPs, just running it on the flows. Here, no detections, okay? This is just looking at the traffic. So far, no machine learning. And here you can see, okay, between this line and this line, it's 5 minutes time window. These are the connections. These are the letters, so no letters in here. 1, 1, 1, 1. We have some in there, and there is no detection yet. So I just want to show you that we have the behavior, see? So looking at the pickup file, here actually we do have the behavior. Okay? We do have the behavior. So what I'm going to do now is that I'm going to apply the models that I generated with the Stratosphere in this capture to see if these behaviors can be detected or not. Okay? Do you follow? No? Yes? Okay. So what I'm going to do is I will create my folder, like test. I will move the the model to the test folder, okay? So there we just have the test folder. And now I will say to my command, look at this. Remember, until this point is just flows, okay? So I will get the flows, I will give the flow to sleeps, I will say sleep, work in 5 minutes time windows, so analyze everything every 5 minutes, and then detect using whatever you're using, your machine learning, using the models that are in the test folder. Okay? So what it's saying is, I will read this model from the test folder, I will read the flows, I will generate the letters, and I will tell you if they are matching. And look at here, it's saying, okay, in the first time window, no matching. Remember that there was a lot of connections in there? So nothing matched. No detection here. Then no detection, another 5 minutes, no detection, another 5 minutes, no detection. And at some point, we have enough flows, and then it's matching and say, hey, this model was detected as from botnet TCP CCC 30. Okay? So here there is a matching. And then in the next time window, 5 minutes time windows, we have another matching. And another. Actually, you can see that it's just getting more flows every time. And the more flows, the more it's matching, and we have a detection. But also, you will see that there is no detection of other things, right? So actually, we are not detecting everything. We are just detecting this behavior of the command and control that was up, okay? There is something in there more. Nothing. Because remember that a lot of behaviors were completely different with age. Remember, there was another one with beats. So these are not matching. Let me show you again without the detection. So without the detection, there are some models like this one that is not similar, and this one is not similar. So a lot of connections from the model are not matching my model. My model is for this type of command and control, this type of malicious behavior. So in this case, you should make one malicious behavior when the command and control is up. Maybe you want a connection when the command and control is down. Maybe you want a behavior with a long command and control, and I think that's it. We don't have time, but if you create a model for the long command and control, the long command and control can detect a small one, okay? So usually with one, it's enough for detecting these two models, okay? Questions so far? I'm sorry about the rush, but we don't have the time.
Quick question.
Yeah.
Your current models are public?
Yes, they are public. Everything is in the webpage. Let me think about this. Yeah. If you download the sleeps software right now, in the models folder, there are, I think, 8 or 10 models that are working. Yes.
Just those.
Yeah. So those are good models. They are not all our models, but they are the public models. And what is more interesting that using the tool, you can create your own. Say, okay, I want to detect this one, and then you just put it there. Okay? Question? Yeah.
And you use only Markov models, or also like different
algorithms? So in this case, it's only micro models because it was our main and first model for this. So right now we are working in neural networks, and we are working in convolutional neural networks, and I'm missing another one. We need something with clustering. So they may be working, but they are not so polished and finished like this one. So we are testing if their performance is so good or not. But the good thing here is that looking at the letters, you can have some idea of other algorithm and you can start implementing them. Okay? So let me see. I want to show you, oh sorry. I want to show you, let me show you the concepts. Five. Yes. You got. Yes. So this one here, okay. This one here, I'm using is another pickup that is coming from another normal connection. In here you will have to believe me because we don't have to see, but it's coming from a normal connection, and when I'm feeding it to the sleeps command with the test model, when I'm feeding it, actually there are no detections. That means that this model in a normal connection is not generating false positives, right? Of course, this is completely biased, okay? Because I'm sure that there is some normal connection out there that may match this, okay? So this is completely small experiment. But it's just to show you that the model can actually match something and not match normal behavior, okay? So going back to what we are doing, yes, that's it, the normal, and that's everything. So I'm sorry we run out of time. I encourage you to try this at home and tell me if it was working or not. Try to generate the models, make the detection, don't believe me, do it and see if it's working, okay? So before we close the class, do we have some questions? Something that was forget there at some point? Yeah.
Yeah. When the researchers try to buy DGA domains before the botnet owners, who pays for that?
Very interesting. Actually, they are not buying them. They are contacting the domain organization and they are working together to fight against it. So it's not easy to do it. You have to be a very well-known organization, and then you contact them, they verify everything. If you are not well-known, they won't even answer your emails. And then you have to prove that you know what you are doing, because he has to take out the domain from someone, maybe, no, or maybe register it like a new one, and it's assigning to you for some time. So usually there is no money involved, but you should be very good at this, right? Like for example, they are putting this header saying we are sinkholing this, so everyone knows that this is being sinkholed, right?
Question: are we building some kind of letters of your own?
Actually, of what?
Letters of domains.
Actually, no. We don't want to do that. And why? Because if we go there, that is reputation based, right? So the thing with reputation based is that it's working, but it's so dynamic and there's so much data that it's very difficult to use it. So imagine that we are putting a list of 5,000 domains per day. Maybe some people is using it for blocking, right? But this is changing every day. So you have to change your detection every day, and then some domains should be taken out. So the maintenance is very, very hard. We prefer to create one model that is going to match any domain. So if you build a model for this behavior, I don't care about the domain. That's the point of using flows and not the content. Actually, it's encrypted, I don't care. The IP address is port 80, I don't care. It's port 443, I just care about the behavior. So you're matching the behavior, I'm suggesting this is suspicious, just look at it, okay? The idea is not only to use this, the idea is to combine, right? Like you have antiviruses, you have IDS, you have reputation systems, and you have this detection there. And also a very, very interesting question. Snort can detect very especially when it's attacking you, right? So you're getting attacked, and Snort says, oh, you're being attacked. This is focusing on the traffic that is going out of your organization. Not going to you, but from you. So actually, we're taking care. I don't care what is going inside and you're being attacked. I want to know if you are already compromised. Were you already attacked successfully? So if you were attacked successfully, you will be starting having these behaviors out, and that's what I want to do. I want to see your weird behaviors going out once that you are infected. Of course, the downside is that you are being infected already. Right? Sorry, this is not preventing measures, it's just after you lose everything maybe. But you are doing it for the well-being of the rest of the people.
So another comment on that is that when you rely on reputation or blacklists, what happens is that, for example, there are several botnets that have their command and controls on hacked websites like WordPress sites, and sometimes people go there like normally, right? So you have a one single domain having two different behaviors, one normal one and one malicious used by command and control servers. And if you blacklist the domain, you will avoid completely the domain. But if you focus on behavior, you can distinguish, okay, this behavior is of this domain behaving malicious in a malicious way, and this behavior is to a domain in a legitimate way, and you can allow one type of behavior and block the other one.
Actually, with this and that idea, you can block a behavior connecting to Google Drive that is malicious, but allow the normal connection to Google Drive. Actually, we run some experiments using peer-to-peer, and we were able to differentiate the normal peer-to-peer torrent behavior and the botnet peer-to-peer behavior. So it's both the same protocol, both the same peer-to-peer, but they're using peer-to-peer in a different way. So we can say, okay, no, this is normal peer-to-peer, don't care. This is a malware using peer-to-peer, which is very nice if you want to allow peer-to-peer, for example. Okay? So before finishing, I want to tell you something about how we plan to continue with this Stratosphere project. And the idea is that we have a very strong focus on helping NGOs, non-governmental organizations, and CSOs, civil society organizations. So the focus on Stratosphere project is from the university to create this free software behavior IPS to help protect NGOs for free. So why are we protecting NGOs for free? Because NGOs are very valuable and political target. Right now, every NGO is being attacked, like the Dalai Lama in Tibet organization is being attacked a lot from China government, and they are losing a lot of information. And they are very valuable, but they don't have the resources, right? They don't have the money for protection. They don't have the people. They don't know what to do. Their goal is not to protect, it's just to be an NGO. So we want to focus there and provide them a very valuable tool that they can use for protection. So this is our focus in Stratosphere. And for that, what we are doing is that we are receiving the flows without data, the flows from NGOs for free, and we are analyzing the traffic in the university, and we are alerting them of what's going on, right? So we are providing this service for them, and in the hope that we can help protect them. And for that, we have a lot of stuff that we can do. I'm putting there all the things we are planning to do in the future, and maybe some of you want to join there. So we have a lot of stuff for also thesis, bachelor thesis, master thesis, the software development subject here. So there is a lot of stuff that can be done. For example, we need development here to build the infrastructure. We need analysts looking at the NGO traffic, looking at the network and see what's going on. So we need some people there that have some skills into analysis, security, also something about machine learning, because this analysis is giving us new malware, right? So these are the skills you need in there. We are also going in the future with Karel. Karel is there. He will tell you now. No, he won't. With Karel, we are mixing Stratosphere with game theory to create a improvement of the defense strategies of networks based on this detection and game theory of how the attacker is attacking. So we want to provide this also and work on this research. So if you are interested in this research, you can also talk with us. There is some game theory there, security, machine learning, and network analysis. And especially from Stratosphere itself, we have a lot of research that can be done. We have a lot of research, for example, for new algorithms in there. He was asking me what are you doing, except Markov chains. So we want to go to XGBoost. I'm not sure if you know this algorithm in there. Reinforcement learning, learning with time. Especially what we want to do is we want to analyze the behavior of the host, not the connection, the behavior of the computer. So what we want to do is, okay, your computer is generating all these behaviors, all these letters. I want to create an algorithm that is making the profile of your computer. Not one connection, all of them. So that's something we are going into the future. If you're interested, you're also welcome there. And you can continue reading it if you want, okay? So, we are finishing here. Thank you very much for staying and coming this late at night, this Thursday. Thank you very much. I really enjoyed it. For me, it was very nice to be back in front of people talking. I miss it a little bit. Well, thank you very much. We are finishing. We want to continue with some ideas like this seminar. That's in the survey. So, okay, it's not there. Yeah, I did it. Sorry. So it's the survey. It's in the document. So if you fill the surveys, we will know how you want to continue this if you want.
Send mailing list.
Huh?
Send mailing list.
Yeah, I did. It's there, right? You see? Yeah, it's there.
If you're going to continue.
Yeah. I will spam there, send an email. So we are finishing here, and we are slowly going to the restaurant from there. Okay. Yes.